What's going on, everyone? Welcome back. Patrick here. Moving on to the next example. This one's going to be pretty tricky, dealing with function notation. A student sent it to me, thought it was a pretty unique question, so wanted to make a video for it. There's going to be lots of algebra here. It's fairly unique. So we're told f of x is a linear function, and then we're told f of 3. This is the unique part over here. You don't see this too often. So f of 3 is equal to 2, and then f of 2 is equal to 1. What is f of 0? So first thing, notice we're told that f of x is a linear function. And if it's a linear function, then we know it's going to be in what format? mx plus b, the equation of a line. And so what we can do is we can use this over here with these two expressions we're given to find out what the m and the b is going to be, what the slope and the b value is going to be, and then we could find out what f of 0 is. Notice f of 0, it's just basically the b value, right? It's the y-intercept. You'd plug in 0 for x, this would go away, and then that would be the b value. But this could have been anything. They could have asked, what's the slope of the line going to be? It's going to be the m value. Or what's f of 3? Then you'd plug in 3 for x here once you have this, this function. But either way, the first step is to find out what the function is. And so the way you do that, the way you organize it with these unique expressions we're given, you first want to find an expression for f of 3. So notice that I'm going to write this clearly over here. If f of x is mx plus b, then what's f of 3 going to be? Well, f of 3, we would just plug in 3 for the x value. It would be 3m plus b, like that. That's what this is over here. And then you move to the outer part, and notice that we're told that f of 3 is equal to 2, but I'm just going to deal with this left side for now. I'll bring the 2 in after. Notice f of 3, what that is going to be, it's going to be f of 3m plus b. Because we know f of 3, as we showed over here, it's the 3m plus b. And so f of 3 is equal to f of 3m plus b. And so what we do now is we take this expression and plug it in for the x value. Because if we have f of x equals mx plus b, well, what's f of 3 going to be? Well, we know it's going to be 3m plus b. What's f of 2 going to be? It's going to be 2m plus b. So we're always plugging in whatever's here into this x value. So what's f of a going to be? It's going to be ma plus b. What's f of a plus 1 going to be? It's going to be m times a plus 1 plus b, like that. Right, so we're always just plugging in for this x value, whatever is here, whether it's a number or whether it's an expression. So same thing, this here, this 3m plus b, we're going to plug in for this x value. And so what we would end up with is we would end up with m times 3m plus b, like that. Right, we took 3m plus b, plugged it in for this x value. So we have the m on the outside, and then we have the plus b. Now, if you simplify this, this would end up being 3m squared plus bm plus b, like that. So that's what the left side ends up being equal to, and we know that that's equal to 2. So what we could do is we could say this is equal to 2, so we can make an equation here. Like that, and that's one of the equations we're going to use to solve for the m and the b. So notice there's two unknowns we're solving for. So we have one equation, but we need another one. And the other one comes from this expression here. So we'll have f of 2 is equal to 1. Well, what's f of 2? we start with that inner bracket. That's going to be 2m plus b. So f of 2 is going to be the same as f of 2m plus b. And then we just take this and plug it in for the x value. So we'd end up with m times 2m plus b, like that. Basically the exact same thing as this, except the 2 was a 3 before. So from here, if we write this in a more simple form, we get that right there. So this expression is what f of 2 is, but we know that that's equal to 1. So we could say that this is equal to 1. So we could rewrite 2m squared plus bm plus b is equal to 1, like that. And now notice we have 2 equations and 2 unknowns, and so we can now solve for those 2 unknowns. So there's multiple ways you can go about this. What I'm going to do is, if you notice, this bm plus b, that term is in both equations. So I'm actually going to isolate for the bm plus b, so I'm going to bring the 3m squared over, so we'll have bm plus b is equal to 2 minus 3m squared. And then over here, same thing. I'm going to leave the bm plus b on the left side and bring the 2m squared over. So we'll have 1 minus 2m squared, like that. Right? So with both of these equations, I got an expression for bm plus b on the right side. Now, that means that, well, this and this are the same, which means this and this have to be the same. And so that's what I'm going to do. I'm going to make 2 minus 3m squared equal to 1 minus 2m squared. And then notice at this point, we have an equation with only one unknown. Right, so there's multiple ways you could have went about this. You could have maybe like isolated for this b over here, brought everything over, and then plugged it in for this b, do a substitution. But ultimately, if you did that, the bm's would cancel out, you would see, and you'd end up with an equation like this. So from here, what we can do is solve for m. So I'm going to bring the 1 over, I'm going to bring the negative 3 over, so we'll have 2 minus 1 equals negative 2m squared plus 3m squared. So this would end up being 1m squared, and this would end up being 1. So m would be square root both sides. The square root of 1 is plus or minus 1. So you got to be careful here, multiple potential cases. Right, so we're going to have to deal with both of those cases, see if they work out. So m can be plus or minus 1. So I'm going to write that over here. So we got to deal with each of these separately. Now notice that if m is equal to 1, so we'll deal with m equaling 1 and then m equaling negative 1. Basically, we got to figure out when m is equal to 1, what's the b value going to be? When m is equal to negative 1, what's the b value going to be? So what we could do is we could plug in this m equals 1 into either of these equations. I'll plug it into the first one. So we'd have 3 times 1 to the power 2 plus b times 1 plus b is equal to 2. So this would end up being 3 plus b is 2b. We got 2 here. 2b is equal to, bring the 3 over, we'll have negative 1. b would end up being, divide both sides by 2, negative 1 over 2. So if m is equal to 1, b is equal to negative 1 over 2. Now watch what happens when m is equal to negative 1. If I plug it into the same equation, we'll have 3 negative 1 to the power 2 plus b times negative 1 plus b is equal to 2. This would end up being 1. Negative 1 to the power 2 is 1 times 3 is 3. Notice this would end up being negative b. We'll have plus b equaling 2. And then watch what happens here. These cancel out and we end up having 3 equaling 2. But notice that that doesn't make sense, right? 3 doesn't equal 2. And so basically this here, m equaling -1, is an invalid solution. Okay, it's not a plausible solution because notice we end up with this over here, and that's a contradiction, right? 3 doesn't equal 2. So m equaling -1 isn't going to work out, so the only solution is m is equal to 1 and b is equal to -1/2 from these two equations here. And now that we have those, we have the line. Notice we'll have f of x equaling, the slope is 1, so 1 times x is just x, and then the b value is -1/2. And so now that we have this, we could answer whatever questions we have about the line. In this case, they're just asking for f of 0, so we'd have 0 minus 1/2, which is -1/2. It's just that b value, like I mentioned before. Right, so that ends up being the final answer to this question. Right, so fairly tricky question, fairly unique one. You don't see something like this coming up too often, where you're combining multiple function notations, but if you do run into something like that, that's how you deal with it.